Okay, let's kick things off with a classic brain teaser. If person A's salary is exactly 10% less than person B's salary, how much more is B's salary than A's? Your instinct probably screams 10%, right? But math can be incredibly tricky, and that instinct is actually completely wrong. And hey, if problems like this sometimes make you want to pull your hair out, I totally get it. Welcome to This Explainer. Today, I'm going to act as your personal math tutor to solve this exact conundrum. And by the time we're done, you'll see exactly why the shifting baselines of percentage math trip up so many people. To do this, we're taking a brilliant set of authentic handwritten math notes and transforming them into a step-by-step problem-solving journey. We're cracking percentages wide open in a highly focused, quick exam review. Here is our agenda. 1. The percentage exam review. 2. The more or less rule. 3. Everyday retail, rice prices. 4. Whole versus parts concepts. And 5. A practice problem on exam marks. Section 1, the percentage exam review. Let's set the stage. We are starting with some raw, authentic study notes labeled Percentage Part 2. They perfectly capture the absolute core challenge here, which is figuring out how to calculate a relative percentage when your baseline just keeps shifting around. See, when you compare A to B, your baseline is B. But when you turn right around and compare B back to A, suddenly your baseline becomes A. It's confusing. Luckily, these notes give us a brilliant cheat code for this exact situation. Section 2, the more or less rule. If you remember literally only one thing from this explainer, make it this shortcut. Instead of getting bogged down in shifting baselines, the rule says to look exclusively at the very first sentence of the question. Does it use the word more or less? If it says more, you take your given percentage, let's call it A, and divide it by 100 plus A. If it says less, you use subtraction. You divide A by 100 minus A. Then, for both, just multiply by 100 to get your final percentage. It's honestly a beautifully simple heuristic. All right, let's apply this to our opening question. Remember? If A's salary is 10% less than B's, let's walk through it together. Step 1, we read that first sentence, and the key phrase is 10% less. Step 2, because it explicitly says less, our rule tells us we have to use the subtraction formula. Step 3, we plug the numbers in. Our percentage A is 10, so our fraction becomes 10 divided by, parentheses, 100 minus 10. Then we multiply that whole thing by 100. Okay, mental math time. 100 minus 10 is 90, so we've got 10 over 90, which simplifies nicely to 1 over 9. Multiply 1/9 by 100, and boom, the calculation gives us exactly 11 and 1/9%. This mathematically proves that a 10% decrease going one way requires a slightly larger percentage increase, 11.11%, to get back to where you started going the other way. Section 3. Everyday retail, rice prices. Now let's take this abstract math and apply it to something you'd actually face at the grocery store. This next example poses a super practical retail scenario. If the price of rice is increased by 10%, by how much percent should a person reduce their consumption so their overall budget isn't affected? Think about it. If a staple gets more expensive, but your budget is fixed, you simply have to eat less of it. But exactly how much less? Let's use our methodology again. Step 1. Note the first part of the problem. It states the price is increased by 10%. Step 2, because it says increased, which means the same thing as more, the rule tells us to add our percentage A to the 100 in our denominator. Step 3, set up the math. We have 10 divided by parentheses, 100 plus 10, all multiplied by 100. That gives us 10 over 110, or 1 over 11 multiplied by 100. And the result is 9 and 1/11%. That is exactly how much your rice consumption must drop to perfectly balance out a 10% price hike. Again, look at that asymmetry. Prices go up by 10%, but you only drop consumption by a little over 9% to keep your budget flat. Pretty fascinating how these numbers interact, right? Section 4, whole versus parts concepts. Let's switch gears and move into what the notes call marks-based questions. Here, we transition from relative changes to finding an absolute total. You're basically acting like a detective. You are given a partial value and a partial percentage. For instance, you might know that the passing marks for a test make up exactly 32% of the whole exam. If you know that piece of the pie, and you can figure out what raw number that 32% represents, you can use basic algebra to deduce the size of the entire 100% pie. Section 5, practice problem, exam marks. All right, time to put it all together. Here is our final scenario.
Raj took a test. He scored 460 marks, but unfortunately, he failed by 40 marks. We're also told that the passing percentage for this exam is 32%. So what are the maximum marks possible on this test? Take a quick second to think about how you'd set this up logically before we dive in.
Okay, let's look at the solution. The very first hurdle is figuring out the actual passing score in raw numbers. We can just use plain logic here. If Raj scored 460 and he was exactly 40 marks short of passing, we literally just add those two numbers together. 460 plus 40 equals 500. So 500 marks is the exact threshold to pass. Now we enter the algebra phase. Step 1, we equate our values. The problem said the pass rate is 32%, and we just calculated the passing score is 500 marks. Since the percentage and the raw value define the exact same thing, they're equal. Step 2, set up the equation. 32% is just 32 over 100, so 32 over 100 times the maximum marks equals 500. Step 3, rearrange to isolate our unknown. To get maximum marks by itself, we multiply both sides by 100, then divide by 32. Our final equation is maximum marks equals 500 times 100 divided by 32. Let's break down the arithmetic. 500 times 100 gives us 50,000. So we have 50,000 divided by 32. We can simplify this by canceling out common factors, bringing it down to 3,125 divided by 2, which works out perfectly, giving us a highly satisfying final answer of 1,562.50 maximum marks for the entire exam. We just took completely fragmented data, a failed score, a margin of failure, and a passing percentage, and worked backwards to uncover the total scope of the test. And that brings us to the end of our exam review. By breaking down calculations into clear, logical steps and learning to map parts to a whole, you can absolutely solve any shifting percentage problem that comes your way. So I'll leave you with this. The next time you are faced with a tricky percentage question, whether it's on a major exam or just calculating a discount at the store, will you remember the first sentence trick?